Alright guys, let's go ahead and talk about atomic structure today. Today we're going to learn about the structure of the atom and what we know about the atom, and we're going to learn about how we can identify different types of atoms. So, all matter is made of atoms. Atoms are the elementary part of matter. Atoms contain a dense nucleus. In fact, almost all of the mass is in the nucleus, and it's surrounded by what is called an electron cloud. So it's surrounded by an electron cloud. And so if you take a look at the picture in your screen here, you can see that we have this nucleus, right? This is where all the protons and neutrons are. And then around the nucleus, you can see that we have the electrons. So what I'm going to say though is the nucleus is actually very, very small. If you were to take an atom and you were to make the nucleus the size of a dime, if you were to put that dime in the middle of Cowboy Stadium, the first electron would be somewhere in the parking lot. And so that just shows you how small the nucleus is. Yet all the mass is in the nucleus. Now, atoms are made of 3 subatomic particles, all right? So those are just particles that are smaller than the atom. And so the first one is a proton. And a proton has a positive charge. It has a positive charge. It is located in the nucleus. We say that it has a mass of 1. That's a 1. Let me go ahead and make that look better. And we can call it we abbreviate as a P with a plus, and so we can put it as a P with a plus, or just a P. Now, a neutron is neutral, and so it has a charge of 0. It also is located in the nucleus. It also has a mass of 1, and we will abbreviate it with an N or an N with a 0, because again it has a 0 charge. Now, an electron is negative. It is not located in the nucleus, but rather it's located in the electron cloud. That makes sense. So it's located in the electron cloud, which again, the electron cloud is around the nucleus. Now, it actually has a mass of 0. So we're going to say that it has a mass of 0. The reality is it actually has a really, really small mass, but the mass is so small that we're going to just say it's 0. So, and the abbreviation is going to be E with a minus, all right? Sometimes we can just use a minus or just E. So, those are the 3 types of subatomic particles: protons, neutrons, and electrons. And so let's go ahead and talk about a few things with the atom. All right, so a lot of this information about protons, neutrons, and electrons can be found on the periodic table. So you can find this on the periodic table. And so I'm going to show you a picture of the periodic table real quick here. Take a look. Here is the periodic table. These are all the elements that are known to man. What I'll say though is that bottom row has actually been completely filled all the way to the last column there. But for the most part, these are all of the elements that we will deal with in this class. And so we will learn more about the periodic table as we go, but this is going to contain all the information that we need about atoms and what they're made of. And so the identity of an element comes from the number of protons. The number of protons will tell you the identity of an element. And if you change the number of protons, you will change the identity of the element. So again, you change the number of protons, you will change the identity of the element. For example, silicon has 14 protons. If you were to add a proton, it would then have 15 protons, and that would end up being, if you take a look on the periodic table, phosphorus, because we're going to learn that this number tells us the number of protons. So, silicon has 14 protons, but if you were to add another proton, it would become phosphorus, and it would no longer be silicon. By the way, you guys want to hear a joke? What do you call a clown who's been to prison? A silicon. Hope you laughed. Anyways, let's go ahead and go back here. We're going to talk about there's four pieces of information that we can get from the periodic table. Now, some periodic tables have a little bit more, some have less, but these are the four main things you can get from the periodic table. The first thing is the atomic number. The atomic number is this number right here. I'm just going to go atomic number. And this number tells you the identity of the element, and it tells you the number of protons. So it tells you the identity and the number of protons. And so it has, so for example, silicon has 14 protons because the atomic number is 14. The next thing is the atomic mass. And what that is, that's an average, that's the average mass of all elements isotopes. And so we're going to learn more about isotopes later. But essentially, this is the atomic mass. And so something to keep in mind is that atomic mass is going to be different than the mass number. We have not learned about the mass number. The next slide will be talking about mass number, but atomic mass is the average mass. Notice how atomic starts with A, average starts with A, and that's how you kind of keep that memorized. So the atomic mass is an average mass. Now the symbol is this right here, and the symbol is a shortened element name, and it always starts with a capital letter. So it always starts with a capital letter. Now, if you take a look at silicon, the symbol for silicon is Si, and notice how it is a capital. I'm going to go to the periodic table real quick, and I'm going to show you some more symbols here. If you take a look, you'll see that oxygen is O. You'll see that fluorine is F, boron is B, and then we've got these weird ones where sodium is actually Na. That's weird. The reason why sodium is Na and not S, well, first of all, S is for sulfur. You can see that right here. However, that's not the only reason why it's not S. The reason why sodium is Na is because probably the Latin word for sodium starts with an N and an A. You can see the same thing with silver here. So silver is Ag, and the word silver doesn't have anything in there, but the Latin word for silver is argentinium. And so that's why it's Ag. And just an interesting history lesson, Argentina was named Argentina because they discovered there was a lot of argentinium there. So when the Portuguese came, they discovered there's a lot of argentinium. Now, I'm not a history major or a history teacher, so I could be a little bit wrong, but it's something along those lines. Just an interesting fact. Now, going back here, we've got one last thing, and that is the name of an atom. So the name is at the bottom, silicon, right? All right, so those are the four things that you need to know about that we're going to use going forward. So let's go ahead and talk about a couple more things here. If you take a look at this next slide here, the mass number is different than the atomic number, all right? So the atomic mass is the average mass, but the mass number is different. The mass number is talking about a specific atom. The mass number is the mass of one individual atom. And it comes from the protons and the neutrons added together. And so if we talk about an individual atom, the protons plus the neutrons will give us the mass number. Now we're going to learn later that some elements will have different numbers of neutrons. And so something to keep in mind is that the mass number is always positive. I mean, not positive, it's always a whole number. And the average atomic mass is the average mass of all of the same existing atoms of a particular element. And so again, it's the average of all of the atoms of a particular element. So to calculate the mass number, again, you take the protons and you add the neutrons. Now, again, reminder, this is like the fourth time I'm saying this, the mass number is not the same as the atomic mass on the periodic table. All right, so let's go ahead and do some practice problems. What element has 47 protons? All right, so what element has 47 protons? Well, what we do is we look at our periodic table and we look at what element has the atomic number of 47. And if you take a look here, this right here has the atomic number of 47. It's silver, so silver has the atomic number 47. And so our answer is silver, so we can write silver, or we can write Ag for silver. Now a neutral atom has 8 electrons. What element is this? Now we didn't really talk about what a neutral atom is, but I'm going to tell you what it is now. A neutral atom is an atom in which the protons and the electrons are equal to each other. Because if you have 8 electrons, for the atom to be neutral, it's got to have 8 protons. Because it's going to have 8 negative charges, for it to be neutral it has to have 8 positive charges. So essentially, for now, electrons and protons will always equal each other, especially if we say it's a neutral atom. So we're going to say, again, electrons are going to be equal to protons. And so if it has 8 electrons, how many protons will it have? Well, it's going to have 8. So what element has 8 protons? You'll see that oxygen has 8 protons. And so what element is this? Oxygen. Because again, for now, what we're saying is that the electrons and the protons are the same. Later on, that'll be different. All right, so how many neutrons are found in chlorine, which has a mass of 35? Okay, so mass, let me go like this. The mass number, take a look at the top of the screen, is equal to the protons plus the neutrons, all right? And what it's asking for the neutrons. It's saying how many neutrons are there. So what it's asking for is this number right here. It gives us the mass number. It gives us the mass number right there. It says that the mass is 35, and we know that the mass is equal to the protons plus the neutrons. Well, how many protons does chlorine have? Well, this is where we're going to look at our periodic table to determine how many protons chlorine has. And so here we go. Let's go ahead, let's find chlorine. It's all the way on the right here. It's this particular element right here. And if you take a look, it has 17 protons because this top number is what tells you the number of protons. So let's go back, and it's got 17 protons. So we're going to go ahead and write 17 here, plus the number of neutrons. So it's plus the number of neutrons, which we don't know. We don't know what the neutrons are. That's what it's actually asking for. So it's asking for the neutrons. And so what we now need to do is we need to figure out what the neutrons are. Well, 17 plus what is 35? All we have to do is take 35, subtract 17, and that will give us the neutrons. And so the neutrons in this situation happen to equal 18. There happens to be 18 neutrons. And this is our answer right there. So there's 18 neutrons, and again, because 17 plus 18 is 35. All right, number 4, what is the mass number of a carbon atom that has 8 neutrons? Okay, so now we're asking for mass number. And again, mass number is equal to the protons plus the neutrons. It tells us the neutrons. And so you can see that we have 8 neutrons. Now it says that it's carbon, and we can find the protons by looking at the periodic table. So let's go ahead and look at the periodic table. And if you take a look at the periodic table, you'll see that carbon is right here, and it has 6 protons. So let's go ahead and go back. And so it's got 6 protons plus 8 neutrons, and that's going to equal 14. So the mass number of a carbon atom that has 8 neutrons is 14, because again, carbon has 6 protons, which we got from the periodic table. The problem is telling us it has 8 neutrons, and so it's 14. Number 5, how does the mass of a proton and electron compare? Well, what I'm going to go ahead and say is the mass of the proton is not equal to the mass of the electron. So the mass of the proton is not equal to the mass of the electron. And so the mass of the proton, if you recall from your notes, if you look back at your notes, the mass of the proton is 1 and the mass of the electron is 0. And so again, they are not equal. So the next question is, well, how does the mass of a proton and a neutron compare to each other? Well, in this situation, the mass of the proton is equal to the mass of the neutron. And so they're equal to each other. And so in this situation, they're the same. So let's go ahead and go on to this next practice problems here. So if you take a look at the top table there, we need to fill out this information. And so we will need the periodic table for this, but we can fill out some things without looking at the periodic table. It turns out that the atomic number is equal to the number of protons. So the atomic number and the number of protons are equal to each other, because again, the number at the top of the periodic of a symbol in the periodic table is the atomic number, and so that means that the atomic number is 26. The other thing we said is that protons are equal to electrons. And so for now, protons will equal electrons. In a future unit, that will be different, but for now they're going to be equal to each other. Now, the mass number, again, what the mass number is, it's the protons plus the neutrons. So it's the protons plus the neutrons. And so all we need to do is take the protons, which is 26, and add the neutrons, which is 31. And if we add those together, we get 57. So it's 57. All right. Well, what about the element name, symbol, and average atomic mass? Well, we have to look at the periodic table for that. So let's go ahead and look at the periodic table. Remember, it has an atomic number of 26. And if you look at the periodic table, what has an atomic number of 26? Well, let's go ahead and find that on here. Here we go. Notice how it's iron. Iron has an atomic number of 26. Notice how the symbol is Fe. That's because the Latin word for iron is ferrous. And so let's go ahead and put in the symbol and the name. All right, so the symbol is Fe, and the name of it is iron. Now, what about the average atomic mass? Well, that is the number that's at the bottom here, which is 55.85. And so the number at the bottom there is 55.85. Notice how the average atomic mass is different than the mass number. The average atomic mass is the mass that's on the periodic table, but the mass number is the mass of that individual atom. And so it's the protons plus the neutrons. All right, let's go ahead and go to these last two things here. So we have boron, which has a mass of 11. And what we're going to do is we're going to draw the structure of an atom. And so boron has the mass of 11. And so what we want to do is we want to figure out how many protons, neutrons, and electrons there are. Well, again, we get the protons from the periodic table. The periodic table tells us the protons. And so if we go over to the periodic table, here's boron. And it's this number right here that tells us how many protons there are, which is 5. And so we have 5 protons. And so we're going to go ahead and put a 5 here because it has 5 protons. Now, again, the protons and the electrons are going to be equal to each other. For now, the protons and electrons will be equal. And the number of neutrons, well, we know that the mass number is going to be the protons plus the neutrons. So we know protons plus neutrons will equal the mass. And if the mass is 11, and if we have 5 protons, then we can just subtract that and we figure out that there's 6 neutrons in the mass. All right, so we have 5 protons, 5 electrons, and 6 neutrons. So let's go ahead and draw an atom. The protons and the neutrons are in the nucleus. And so what we're going to do is we can do a couple things. So we can just go like this. We can draw 5 protons, right? And then we can put 1, 2, 3, 4, 5, 6 neutrons. And so we can do something like that. And so you can see that there's 5 protons and 6 neutrons. Now what we'll do is we will draw energy levels, because the electrons live in the electron cloud, so we're going to draw specific energy levels. And again, Niels Bohr is the one who came up with the fact that electrons live in specific energy levels. There we go. Okay. And we're going to draw some electrons in there. And so how many electrons go on the first energy level? Well, the first energy level will have 2 electrons. So what we do is we draw 2 electrons. How many electrons can go on the second energy level? Well, you can have a total of 8 electrons on the second energy level. However, for boron, there will not be 8 electrons on the second energy level, because how many total electrons are there? There's 5 total electrons. We've already shown that there's 2 on the first energy level. So that means that there's going to be 3 on the second energy level. And for now, just go like this. Notice how I'm spreading them out like this. And we will just talk about that actually in a couple units. So we'll learn about how electrons are specifically oriented, but we'll start practicing it right now. All right. So that is the atomic structure of a boron atom. Let's go ahead and do the same thing for a sodium atom. I'm going to do something a little bit different though. I'm going to instead of writing all the positives and negatives, I'm just going to go. I'm just going to write P and N, but we'll talk about that in a moment. So let's figure out the protons. Well, sodium. If we take a look at a sodium atom, here is the sodium atom. And you'll see that there's 11 protons. You'll see there's 11 protons. So a sodium atom has 11 protons. We're saying that the protons and the electrons are the same for now. And the mass is 23. We know that the protons plus the neutrons are equal to the mass. So if we have 11 protons, that means that we're going to have 12 neutrons to equal a mass of 23, because we know that 11 plus 12 is 23. So in this situation, what we're going to do is, instead of writing positives and zeros, we're just going to write 11p. So there's 11p, and there's going to be 12n in the nucleus. So we have 11 protons and 12 neutrons in the nucleus. And so what we're going to do is add our electron cloud, or energy levels here. And again, it was Niels Bohr who came up with this, came up with the Bohr model with the... There we go. Okay, it's not perfect, but oh well. So now we're going to add electrons. How many electrons go in the first energy level? 2. 2 electrons will go in the first energy level. How many go in the second energy level? 8 electrons go in the second energy level. But how many electrons does sodium have? It has 11. And we've already written 2 of them, so that means that there's 9 left. And so what that means is that there will actually be 8 electrons in the second energy level. And again, what we want to do is we want to write it like this. We want to go 1, 2, 3, 4, and then we actually start to pair up the electrons after 4. Then we go 5, 6, 7, 8. And so again, we go 1, 2, 3, 4, and then we start to pair them up as we go around. Now, if you take a look, how many total electrons have I written down so far? Well, there's 2 on the first energy level. There's 8 on the second energy level for a total of 10. And so that means that we have 1 more electron to write down, because there's a total of 11 electrons. How many electrons go in the third energy level? Well, 8, although later we'll learn it's 18. I keep saying that. But because 8 can go on the third energy level and we only have to write one more, we can just write that one more on the third energy level. And so if you take a look, sodium will have 1 electron on its outermost level. And later we'll learn that's called the valence level. But that's the sodium atom. And so take a look at the boron model and take a look at the sodium model. Notice how you can either write the positive charges or you can write 11p, the number of protons. You can do either way. And so go ahead and take a look at this. If you need to rewatch a couple things, definitely do that. If you have any questions, feel free to email me, and I hope you guys have a great day.